So today I'm going to be talking about linear equations, and there are two main forms. There is slope-intercept form and point-slope form. And when we look at these forms, there are like certain key components we have to know. So for slope-intercept form, m is going to represent the slope. So m represents the slope. And when to calculate slope, we use this formula. M equals y1 minus y over x1 minus x, where the x and y values are just points on the graph. So the x1 comma y1 value would just be one coordinate, and the x comma y value is going to be a different coordinate. And that kind of goes hand in hand with the x and y variables. These are going to be variables, so they will always be referred to as x and y in the equation, but they're just going to be coordinates on the graph, so any coordinate on the graph. And the b value, b is the y-intercept. And we'll go more into this in a second. So those are the key components for slope-intercept form. But for point-slope form, it's similar but a bit different. M is still going to be the slope. So m is still going to be slope either way. And of course, the y and the x values are still going to be variables in the equation. So they're always going to be y and x, or x and y, either way. And then, but the x1 and y1 values, these are constant. So they're going to be numbers. They're going to be like numbers when you put them into the equation. So if you have they're just a coordinate on the linear equation or the linear graph. So if you have the coordinate 3, 6, then you would plug in 3 for your x1 value and 6 for your y1 value, and that will be the equation for the graph. So it'd be y minus 6 equals, and if the slope is 1 over 2 times x minus 3. So this would be an equation. So now let's go into some examples. So if we look at this graph here, this is your most basic type of linear graph. So let's first calculate the slope. So m equals, and all of the equations are up here in the top right. So if we find 2 points on the graph, let's take this one right here, 1, 1, and let's take this one right here. And it does not matter what 2 points you use. As long as they are on this line graph, it'll give you the right slope, 3, 3. So it doesn't matter what coordinates you set as your x, y value and your x1, y1 value. It doesn't matter. So set this one as our x1, y1 value. And this is our x, y value. So if we plug these in, we get m equals, our y1 value is going to be 3. Our y value is going to be 1. Our x1 value is going to be 3. And our y value is going to be 1. Or x value is going to be 1. So that means we get m equals 3 minus 1 over 3 minus 1. And m equals 2 over 2. M equals 1. So our slope is going to be 1. So when we look at these two equations up here, the m values are going to be 1. So you get y equals 1x plus b, which is commonly referred to as y equals x plus b, because 1 times x is just going to be x. And we get y minus y1 equals 1 times x minus x1. And you can get rid of the 1 also. It doesn't matter. So now we know this is true because if we look at the graph, basically what this 1 means is that every time you go over 1 on the x-axis, you're going to go up 1 on the y-axis. So every time we go over 1 on the x-axis, you go up 1 on the y-axis. Over 1, up 1, over 1, up 1. And we can see how all of these points are on the graph. So we know the slope is right. So now we are left with these two equations down here. But as you can see, they both have unknown constants. This one has an unknown b value. This one has unknown y1 and x1 value. So to solve for this b value, y equals 1x plus b, or y equals x plus b. It doesn't matter. So to solve for b, what we want to do, is simply plug in an x and y coordinate. You can use any coordinate on the graph. So let's use 3, 3. So 3 equals 3 plus b. So 0 equals b. So b equals 0, and therefore y equals x is an equation of this graph. If you want to use the point slope form, then all you have to do is use any coordinate and plug in for the y1 and the x1 values. So if we use 3, 3 again, we will get y minus 3 equals x minus 3. So that would be point slope form. Or you can also add this one here to indicate slope. So this slope intercept form, this point slope form. So now if we go into a more complicated problem, we can kind of see the components in more depth. So if we get rid of all of this, give me 1 second. Oops. So if we get rid of all these values, so now we're just left with our basic graph again. And I'm even going to erase this and draw a new one. So if we draw a graph and it looks something like this. So now if we want to find the two equations again, we'll use the same formulas to find the equation. So to find slope, m equals y1 minus y. So let's find 2 points on this graph. We can use any 2 points. We'll use this point right here, which is at 2 right here, comma 3. And we will use this point right here. Again, it doesn't matter what 2 points you use, but you want to use ones that are on like a crosshair right here so that you get whole numbers for your x and y values. So 2, 3 and 6, 5. So m equals, and it doesn't matter which one's your x1 and y1 values and which one's your x1 values. So we'll set this to x1, y1, and this to your x, y. So I plug this in. So y1 is going to equal 3 minus y is going to equal 5 over y1 is going to equal 3. I'm sorry. Excuse me. X1 is going to equal 2 minus, and your x value is going to be 6. So when we simplify this, we get 3 minus 5 equals negative 2 on top over 2 minus 6 equals negative 4, which equals 1 over 2 because negatives cancel out. So the slope equals 1 over 2. And we know this is true because when you think of slope and you hear something like 1 over 2, you can think of it goes up 1 every time you go over 2. Over 2. So every time we go over 2, we go up 1. Over 2, up 1. So we get that slope. So y equals 1 over 2x plus b using point slope or slope intercept formula. So now we can plug in any coordinate. Let's use the coordinate 6, 5. It doesn't matter which. So we plug in 6. So 5 equals. We plug in 6, 5. So y equals 5, and x equals 6. So 5 equals 1 over 2 times 6 plus b. So 5 equals 3 plus b. So therefore b equals 2. So the equation in slope-intercept form is y equals 1 over 2x plus b. And as I said earlier, this b value is going to be our y-intercept. And basically y-intercept just means what y equals when x is 0. So when x is 0, and this point is called, so this point down here is called the origin also. Right here. But when x equals 0, what does y equal? Y equals 2. This is known as y-intercept, or where the graph crosses the y-axis. This is a y-axis, this is a y-axis, and this is the x-axis. So where the graph crosses the y-axis. And as you can see, when the graph crosses the y-axis, the y value is 2. And we know this because if we plug in 0 for x, we get 0 times 1 over 2, which is 0 plus 2. Which equals 2. So that's why the b value is going to equal wherever the graph crosses the y-axis. So that's for slope-intercept form. And now if we look at point-slope form, it's similar. So we get y minus y1 equals 1 over 2. Oops, ran out of room. Let me scoot this over. Y minus, let me draw a line right there. Y minus y1 equals 1 over 2 times x minus x1. So now all we do is take any coordinate and plug it in for the y1 and x1 values. So if we use 3, 2 or 6, 5, doesn't matter, but we use 2, 3, I'm sorry, 2, 3. So the y1 value will be 3, y minus 3 equals 1 over 2 times x minus, and the x value is 2, or the x1 value is 2. So x minus 2. So this will be your point slope form equation. So y minus 3 equals 1 over 2 times x minus 2. So those are the two forms. And some key components, if we have a different graph that looks something like, I'll draw in a different color. If we have a different graph that looks something like, that looks something like this. So, some key components of this graph are the y-intercept. The y-intercept is still going to be at y equals 4. So the y-intercept is going to be at 0, 4. So b is going to equal 4. For this, I'll write this over here. So b equals 4 for this equation. And then the slope, what you have to know is when a graph is going down like this, the slope is going to be negative. So m is going to be a negative number. So if we solve for the slope, if we go over here and solve for the slope, we get m equals, and let's find 2 points on this graph. Now the graph only has 2 points where it crosses at whole numbers. So we'll take this point right here, 0, 4, and this point down here at 5, 0, and use that to find slope. So we'll set this as our x, y value, and this down here will be our x1, y1 value. So y1 is going to be 0 minus y is going to be 4 over x1 is going to be 5 minus x is going to be 0. So m equals negative 4 over 5. So m equals negative 4 over 5. As you can see, the value is negative. And we know this is right because what this is saying is when you go over 5, this negative is saying every time you go over 5, you go down 4 instead of up 4. So every time we go over 5, 1, 2, 3, 4, 5, we go down 4. 1, 2, 3, 4. And as you can see, you get to a point on the graph. So those are the key components of linear equations, and you just have to remember slope, and mainly slope and y-intercept, and how the y-intercept is simply where the equation crosses the y-axis over here, the y-axis, and how the slope is just the angle or the rate at which the graph is going up or down. And if the graph is going up, the slope is going to be positive. If the graph is going down, it's going to be negative. And you can always calculate the slope just by counting how far the graph goes over and then up, or over and then down if it's negative, right? Over and then down. So those are key components. That's the majority of what you have to know for linear equations for Algebra 1. So good luck and have a good day.